welcome you to this lecture of vector calculus. So in this lecture, I will talk about the curl, okay, of a vector field. So suppose we have one vector field, let's say f of x y, and we want to find out the curl of this function. Then this is basically written in this way: curl of f of x y, that is the cross product. So previously divergence, it was a dot product, so it is the cross product. So cross product we can find out by using this determinant. Okay, so this is with the determinant things, and the determinant way it is easy to write. So first row it is I j k, then del a, del x, del y, del z, and f1, f2, f3, the three component of this function. Now by evaluating of this determinant, I can find out the curl of this vector field. Now curl, you can see that is basically a vector quantity, right? It is a vector field because I j k is also present. Now what happened is, if that curl of a vector field is 0, then you can see that if the curl is 0, then it is called basically the irrotational, because all the components of the vector also will be 0. Okay, now let's find out the curl of some vector field. So first example, we have this function. Let's say f x y is equal to 3x square I plus 2xy j plus 4xy z k. Okay. Now to find out, sorry, so I have z also, right, because it's function of x y z. So I have to calculate what is the determinant of this thing. So ultimately I have to find out this determinant, and f1 I know that is 3x square, and f2 I know that is 2 of xy, and f3 is 4xyz, right. So after that, if I expand with respect to the first row, then it will be partial derivative of this one with respect to y. So this one will be 4xz, and here with respect to z, that is 0 I, and for j it will be negative, right, and this one, that is 4 of yz, negative of 0, right, and for the k it is here to here, that is 2y, and this is 0. Okay, so after simplification I can say that is 4 of xz I, and negative of 4 of yzj, and 2yk. Now another example, suppose we have this simple vector that is f of x y z, sorry, here x y z will be there, that is equal to x I y z z k. So in this case I'll get this determinant, this f1 is equal to x, and f2 equal to y, and f3 equal to z, right. So now we have to find out the determinant. So here you see, when I partial derive this one with respect to y, it will be 0, it's also 0, and similarly for j it is 0, ultimately it's a 0 vector. Therefore we can say this vector f of x y z, this one is irrotational, right. Okay, thank you for your kind attention.